Welcome to day 21 for solving problem of the day from GFG. So let's look at today's problem. So this is our problem. Given a singly linked list of n nodes, find the first node of the loop if the linked list has a loop. If a loop is present, return the node data of the first node of the loop, else return -1. So let's understand the problem using an example. It's a very easy problem. So we have given this linked list. This is like this. Okay. So you are seeing that from here, actually this is a loop. Okay. So from here, the node is coming here, then here, then here, then again here. So this is the start of this loop. Okay. So here the loop is actually starting. So first find the loop. The loop is this, and the first node from which it is starting is this node. So I have to return this node value. Okay, nothing else. So it's very easy. First understand something is that suppose this is a line and this is some labels, and here is someone and here is someone. Okay, so suppose this man is going what can I say, this man is going forward by one step, and this man is going forward by one step also. So after one step, this man will become here, and this man will become here, right? After again one step, this man become here, and this man become here. So you are seeing that they are never gonna meet each other in a common place, common level. Okay. So same for the loop also. Suppose this is some places, one man is here, one man is here. So if this man goes by one step and this man also simultaneously goes by one step, they're gonna never meet each other. Okay, because this man will be here and this man will be here. So both are just moving one step forward, so they're gonna never meet each other. But what if we push this man by one step and this man by two step? Okay, so this man will be here, but this man will be here. Yeah, so actually in by this one step forwarding and this two step forwarding, we get these two mans at the same position. So what we can imagine that if there is a cycle and there is a node, there are many nodes, and if I keep a pointer here, which is suppose I, and suppose here is some another pointer j, this is for keep forwarding by just x step suppose, and this is keep forwarding by suppose x plus some y steps. So it is guaranteed that somehow somewhere they should meet each other in a common place. Okay, because if this man goes by one step, this man goes by one step, this man goes one step, this one goes one step, so they are gonna never meet each other. But if we increase the step number, okay, where x plus y is suppose greater than x, and they somewhere they will meet each other definitely. So let's put y as x, so we get this as 2x and this as x. Okay, so there are nothing wrong actually. You can put this by x plus 2 also, or you can put x plus 3 also. They will definitely meet each other one day. So what we are going to do by this? Okay, what we are going to do by this? So first I will keep a pointer here I and j. I will forward this by one step and forward this by two steps. So this becomes here, this becomes here. So after again one step, this becomes here, this becomes here. After again one step, this becomes here and this becomes here. After again one step, this becomes here and this becomes here. So this is the point where I and j meets together, right? So suppose this length is x. For in this case, this is only one. Okay, so 1, 2, 3. There is only one way. There are one way of length L, of length 1. And what I mean to say is there is, suppose up to this there is suppose x nodes, and in this cycle suppose y nodes are there. Okay, and suppose this length where up to where it meets together is length k. So length k is the number of nodes till this point. Okay, so in this case this is 1, 2, 3, 4. Okay, so what I want to say is that what will be the length that I will cover? Let's calculate. So I will cover x plus, suppose after x cycles, let the node in the cycle be number of nodes in this cycle be suppose n. Let's assume that after a cycles, covering a cycles and k nodes, I pointer will reach here. In our case a is 0 because after only this 1, 2, 3, 4 steps it reaches here. So after k it reaches here, and j will reach after x plus suppose b cycles plus 2k, right? Oh sorry, k. So what I am trying to say is that this is suppose the cycle. So I will go by their x step, and suppose it goes a cycles and then again k step, and j go another also goes x step, then again b cycles, then k step, then it reaches here where I reaches. Okay, so the distance covered by j is actually twice the distance covered by I. So what we get, 2x plus 2an plus 2k is actually x plus bn plus k. So x plus b x plus, I can say 2a minus b n plus k is 0, or I can say x is x plus k is b minus 2n n, b minus 2a n. So this is an integer, right? Let this be some L. So x is actually ln minus k. Okay, so x is ln minus k. Okay, so in our case our x is 1, our n is 1 2 3 4, our a is 0, b is 1 because after one cycle, and how j goes, j goes from here to here, then here, then here, then here, right? So it covers one cycle and 1 2 3 4, it covers one cycle and 4 steps. So a equal to 0, b equal to 1, and our k is 4. So x is actually b minus 2a into n, b minus 2a into n minus k. I think after 1 2 3, yeah, okay, so k will be not, k will be 3. From here this distance is k, right? So it covers one step, second step, third step, as in this length is 1 only. For this length this is 1 2 3. So up to here, so let me clear one thing, is what is this length L, x, k are saying. So here is 1, here is 3, here is 2 4 5, like this, right? So up to here means taking only this node, this is my x. So up to here means taking only this nodes. So this is my actually k means. So x is equal to 1, k is equal to 3, and n means this total cycle, that is 1 2 3 4, 4 nodes. So that is why my n is 4, right? So this is actually 3. So my this is x is 1, right? So that is the x. So that means that traveling this distance is actually equivalent to traveling this distance, that is here to here, the common position to this first node. Okay, so x is equal to ln minus I, right? So this is actually like this. Okay, so ln minus I means this is the so see, we covered L times this cycle, Ln, that means L times this cycle. So we covered L times this cycle, so forget about that one. So now after that, after covering L times cycle, we covered I from here to here. Okay, then the remaining part is 5 to 3, right? So 5 to 3 is 1, the length is 1. So this length is actually x. Okay, so this length from here to here is actually my x. So that means if there is a cycle and this is the common point for I and j, then traveling here to here will be equivalent to traveling here to here. Okay, so what we will do is 1 3 2 4 5. What we'll do is we will keep a pointer here and here, and we'll start going I by 2 steps, I by 1 step and j by 2 step. At some point, say here, I reaches here and j reaches here. So we will keep my j here and I will place my I again here. Okay, I will place my I again here. So as traveling j to this node, that is ln minus I, is equivalent to traveling this distance, that is x. So I will travel here to here and here to here. That means I will travel until my I not equal to j. I will create a loop, and this terminus means I equal to j. That means I will get the position where I equal to j, which is the first position of my loop. So this is the thing actually. So this is a common thing, very tricky thing that I will do. So let's code now. So what I'm gonna do is create a node called slow, which will go very slow. That is, slow is called slow, and a node fast, which will go very fast. That is fast is called fast. Will go until this happens. We are going once for slow and twice for fast. So twice means dot next, right? So we'll go by slow equal to slow dot next and fast equal to fast dot next. If somehow in this case slow becomes fast, that means we reaches that point where they are at same position, right? So this is the thing actually. So this is the thing. That means somewhere between here to here they meet at common position. So what we will do then? We will just move slow to my beginning, that is head, and keep a loop until my slow becomes fast. Okay. Yeah, I will do slow equal to slow dot next and fast. So suppose I and j are here at this position, I and j are here, right? So what we will do, we will move we will just move I to this first position, and we will go for j like this and I like this. So after some step they will again meet, and that will be the first position of the loop, right? So this loop terminates means we got the first position. So I will just return slow dot data. Otherwise I will return -1. There may be a case where my head or head dot next is null. In that case, what will I do? I will return again -1. Let's compile it. Why it's taking so time?